Plutonium-238 is used in bombs and power plants but is dangerously radioactive. It decays very slowly into non-radioactive materials. If you started with 100 grams today, a year from now you would have 99.2 grams. A. Construct an exponential function to describe the decay of plutonium-238 over time. B. How much of the original 100 grams of plutonium-238 would be left after 50 years and after 500 years. Well, first of all, let's recall the form of an exponential decay function. The form of an exponential decay function is a of x is equal to c times a to the x, where a is a number between 0 and 1. The c value is the initial amount, and the a value is the decay factor. Well, let's take a look and see what we're given. It says we started with 100 grams today. That means that the amount after 0 days is equal to 100. Secondly, we're told that a year from now you would have 99.2 grams. So the amount after 1 year is equal to 99.2 grams. So we can use these two pieces of information to help us to figure out the values of c and the values of a, and thus our exponential function. So let's start off with a of 0 is equal to 100. We'll substitute 100 for the amount and 0 for x. So a of 0 is equal to 100, so we get 100 is equal to c times a raised to the 0 power. When x is 0, a of 0 is equal to 100. Well, a to the 0 is equal to 1, and 1 times c is c, so we've just learned that c is equal to 100. So our function is a of x is equal to 100 multiplied by a raised to the x. We just have to figure out what is the value of a. Well, to figure out the value of a, we can use our second piece of information. We know that if we substitute 1 for x, that the output has to be 99.2. So we substitute 99.2 for a of 1, and we substitute 1 for x. Well, a to the first is just a. So we'll divide both sides by 100 to figure out the value of a. Just divide both sides by 100 and we get a is equal to 99.2 divided by 100. So to find 99.2 divided by 100, we simply move the decimal place 2 places to the left, and we find out that a is equal to 0.992. A is equal to 0.992. So our exponential decay function is a of x is equal to 100 multiplied by 0.992 raised to the x power. In part B, we're asked how much the original 100 grams of plutonium-238 would be left after 50 years. Well, we just have to substitute 50 for x in our formula and then evaluate the result. So we want to find out what is the amount after 50 years. So we just substitute 50 for x and we get 100 multiplied by 0.992 raised to the 50 power, and then we use our calculator to evaluate that expression. 100 multiplied by 0.992 raised to the 50 power, and that's approximately 66.9. So the answer to the first question, how much of the original 100 grams of plutonium-238 would be left after 50 years, approximately 66.9 grams would be left after 50 years. How about after 500 years? Well, all we have to do is go back to our function and substitute 500 for x. So the amount after 500 years is equal to 100 multiplied by 0.992 raised to the 500 power, and then we evaluate that on our calculator. 100 times 0.992 raised to the 500, and that is approximately 1.8 grams. So after 500 years, approximately 1.8 grams of the original 100 grams would remain.